Hello and welcome to today's tutorial on graphing polynomial equations. As the title implies, today we will look at graphing polynomial equations, as well as we will examine something else called writing equations from quadratic functions. I'm just going to write an E from Q graphs. So equations from quadratic graphs. First things first, let's look at graphing polynomial equations, and this will take up some time. And to graph polynomial equations, I told you in the last lecture that we had to look at something called multiplicity. And indeed, multiplicity holds a very important part of graphing a polynomial function. If a multiplicity is even, if multiplicity is even, then this is, of course, a multiplicity is referring to an x-intercept point, then the graph will touch intercept. And this is going to become very, very useful actually, as soon as we get through this. And if the multiplicity, so I'm just going to write m for multiplicity, if m equals odd, if multiplicity is odd, then the graph will go our x-intercept. So if multiplicity is even, then the graph will touch an intercept, whereas if multiplicity is odd, a graph will go through the intercept. So let's take a look at our equation y equals x minus 1 squared times x minus 1. Oh wait, x plus 1 squared minus x minus 1 rather. And this, of course, came from the original equation, y equals x cubed plus x squared minus x. So this came from y equals x cubed minus x squared minus x plus x squared minus x plus x squared minus x plus or minus 1. It was minus 1. So evidently, it goes without saying that the first step to graphing a polynomial equation is to rewrite the equation in intercept form, because the intercept form is what we're going to use to actually graph the equation. And now let's draw ourselves a Cartesian plane where we will graph this equation. This looks about right. Now we have to find all the intercepts. All the intercepts, meaning the y-intercept as well as the x-intercept. There's going to be several x-intercepts, whereas there's going to be only one y-intercept, because that's what makes it a function. So negative 1 is over here, and positive 1 is over here. Next, we have to look at the end behavior of the graph, where we're going to start, whether up here, up here, up here, up here. And if you recall, in the previous lecture, this is how we determined end behavior. We found two values for x, so we're going to do that same exact thing here. Well, when x equals negative 100, negative 100 cubed is still going to be a negative number. So we're going to start down here. I'm just going to draw a little line right here, just saying we're going to start right there. And we're going to end where? Well, we're going to end up here, because 100 cubed is still a positive number. So we're going to end over here, we're going to start over here, we're going to end over here, and we're going to pass through these points, but we got to find something else. We're going to find the y-intercept. How do we do this? Well, if the y-intercept exists, then the x must be 0, so let's go ahead and let's take 0. Let's find the 0. Let's find y-intercept rather. So 0 cubed is 0, 0 squared is 0, minus 0, so 0 plus 0 minus 0, that's 0, negative 1. So our y-intercept is right here. And now it becomes a matter of graphing this equation. Well, there's a multiplicity going on here. This x plus 1 factor, the negative 1 intercept rather, has a multiplicity. And if something has a multiplicity, then it will touch an intercept, but it won't go past it, whereas if something has an odd multiplicity, then it'll go through an intercept. This has a multiplicity of 1. Ergo, it's going to go through the intercept and keep going. So now what we do is we take this end behavior, we're going to go up through here because it's going to go up, and then it's going to touch our x minus 1 factor, x plus 1 factor, which has a multiplicity of 2, and therefore it'll just go down. It'll touch, but it'll continue down here. and then it'll touch this. But then as soon as it touches this, it's going to what? It's going to have to go up to here, right? So we're going to draw it down here, and it's going to go up to here. But then as soon as it touches this one, x minus 1, this multiplicity is odd. So it'll go through the intercept, making sense, and then go up to here. So I've graphed this equation. That is how the equation looks like. That is what the equation looks like, rather. And we can do this for a lot of different equations. Let's graph that previous one that we found. It was, let's look over here. Let's look for this. It was 2x minus 2 squared, x plus 4. So let me just see if I can just drag this down. Just drag this entire thing. Copy. Just drag this down. Drag this down. Oh, I got the box, but do I actually have the equation? Yes, I do. Just put this inside here. Beauty of technology. And we're going to probably want to slightly orient this. Or we're going to take out this box. We'll delete the box. So as you can see from our equation, which was originally, I'll give you the original equation. It was y equals 2x cubed minus 24x plus 32. As I've said, the first step to graph an equation is to rewrite the equation in intercept form. And the 2 is not going to really be used much because we're not going to find a usage for the 2 because it's just going to affect the curvature of our line, but it's not going to really affect the points as much. So the same intercept still exists. It'll just be a little bit more tight. It'll be a vertical stretch is what it's going to be. So first things first, we're going to have to graph the intercept. So 1, 2 over there, x minus 2, positive, negative 1, 2, 3, 4 over there. Now we must find the y-intercept. Well, we could do several things. We could find the y-intercept, or we could find the end behavior. I'm going to find the y-intercept first. So y-intercept, that's when x is equal to 0. So this is going to go away, this is going to go away. We're going to get 32, so we're going to put that way up there. And it's going to touch 32 and come back down. Yeah, it's going to be crazy. Now we got to find the end behavior of the graph. In order to do that, negative 100, the same thing we've always done, negative 100. Still it's going to be a negative number, so it's going to start down there. It's going to start down there. And then positive, it's going to end up there. So now we got to figure this out. Well, when a multiplicity is odd, a graph will go through the intercept. So therefore, when we're drawing this equation out, it's going to hit negative 4 and keep going up. And then where's it going to go to? Well, the next point that we know is it's going to go up to that equation up there. And then it's going to fall down here. But as soon as it falls down there, since this multiplicity, since this root, this is a double root, and this multiplicity is even, it's going to go straight through there. And I'm trying to really emphasize the fact that it's going to be a smooth curve, because that's really what makes a polynomial function. So let me just try to redraw that. That's kind of going to look like when I have one of these shapes. Looks pretty cool, right? So that's basically graphing polynomial equations. I'll give you a set of rules right now. First things first, we're going to want to write equation in intercept form, which is going to be 2 times x minus 2 squared x plus 4, or maybe x plus 1 squared x minus 1 to the first power. Next, graph x intercepts. Graph the x intercepts, which meaning so on and so forth. This and this. There were two x intercepts in this problem. There were three solutions. 1 plus 2, 3. 3 solutions, but there's only 2. Next, graph y-intercept. We're going to graph the y-intercept. And after that's done, we're going to use the multiplicity rules. Use the multiplicity rules to find shape.